Hey there, welcome to this video on sum and difference identities. In this video, we're going to go ahead and introduce you to the sum and difference identities and kind of how we can use them to help us solve trigonometric equations. All right, so I'm going to start out showing you the special right triangles. And if you recall, because of the special kind of relationship and the proportional relationship between the side measures and the angles, we can easily find trig values for our special angles, which are 30 degrees, 60 degrees, and 45, right? So for our unit circle angles, we have these nice coordinate locations, okay? But what if I didn't use pi 6? What if I didn't use pi 4ths? What if I didn't have pi 3rds? Okay, so let's go ahead and look at considering different angles, right, that are maybe made up of our unit circles. So exact values of trigonometric functions of other angles can sometimes be found using identities. The sum and difference identities allow us to find the exact values of trigonometric functions of angles where the angle value is equal to either the sum or the difference of two unit circle angles. Okay, so that's where it gets its name, sum and difference. And we're going to go ahead and look at this. But first, I want to kind of introduce you to the idea. So say I wanted to find an angle of 15 degrees. Well, wouldn't you agree that 15 degrees is 45 minus 30? And I know the coordinate locations of a 45-degree angle and a 30-degree angle, right? Okay, so converted to radians, this would be pi 4ths minus pi 6 would give us pi over 12. Okay, that would be a difference, right? Subtraction. Okay, well, what if I wanted to go ahead and find a 75-degree angle? Well, using, again, the angles that I know that 30 degrees and 45 degrees makes up 70. Okay, so I could add those together, those angles together, right, to give us 75. Okay, and that's kind of what we're going to do. So to find an exact trigonometric value for angles with reference angles of pi 12ths and 5 pi 12ths, okay, so 15 degrees and 75 degrees, we're going to use sum and difference identities. So here are the sum and difference identities. And I'm just going to first introduce you to the very first one here, which is sine of alpha plus beta. And first, I just want to identify those symbols for you right here. So this is alpha, okay, and, this is beta. Okay, so Greek letters, right, alpha and beta. And here it says sine of alpha plus beta is equal to sine of alpha times cosine of beta plus cosine of alpha times sine of beta. We also have the difference identity with sine of alpha minus beta. Okay, so that's sine of alpha times cosine beta minus cosine alpha times sine beta. And then we have the same identities for cosine. I want you to pause the video. I want you to kind of look for any patterns and maybe see if you catch anything. All right, hopefully you paused and kind of thought about maybe some patterns to help you memorize this. On the test, if we're gonna go ahead and take the test, you will have a kind of the sum and difference identities given to you as of right now. So, but pattern-wise, what I hope you notice is that it's always, so for sine, it's always sine times cosine plus cosine times sine. So that kind of pattern, right, holds true. So you can see that both for the sines, right? And then in between, so for the sine, if it's addition, you're adding, okay? And if it is subtraction, you're subtracting, okay? Cosine, what I hope you noticed for cosine is that cosine is always cosine times cosine, okay? And then minus or plus sine times sine. So there's that pattern. And then I hope you notice also that for the operations, it's switched. So if I'm adding, I'm going to subtract. And if I'm subtracting, I'm going to add, okay? And then the angles, obviously, right, it's always alpha and then beta. Alpha and then beta. Okay, so let's go ahead and look at some steps. So first, we're going to write the angle as a sum or a difference of unit circles. So I first need to know, okay, what's my alpha and what's my beta going to be? Then secondly, we'll use that corresponding identity. Third, we'll substitute the unit circle angles into the identity for alpha and beta. We'll substitute the corresponding values of sine and cosine into the identity. We'll simplify and then write our answer. Okay, let's go ahead and look at an example. So here they want us to find the exact value of cosine of pi twelfths. Okay, so the first thing that I need to do is I need to find an angle. I need to figure out, okay, what is pi over 12? Okay, and one good thing is to maybe think about your main unit angles. So if I have pi over 3, if I have pi over 4, and pi over, you know what, I'm going to flip this. Whoop, pi over 6. Pi over 6. So what would these be in terms of pi twelfths? Okay, so this would be 2 pi over 12. This would be 3 pi over 12. And this would be 4 pi over 12. Okay, and how do I get pi twelfths? Well, I could subtract any two of these, right? I hope you would agree that pi twelfths is 3 pi over 12, right, minus 2 pi over 12. And again, I could use, right, 4 pi minus 3 pi over 12. That would be the same thing. But I'm going to use 3 pi over 12 and 2 pi over 12, right? And these just reduce to pi fourths minus pi 6. Okay, so I'm going to use here a difference identity, right, because I'm subtracting. So this is going to be alpha, and this is going to be beta. Okay, so step 2, I need to know, okay, what trigonometric identity am I going to use? Well, because it is cosine, okay, I'm going to use cosine, and because it is subtraction, I'm going to use the difference. So cosine of alpha minus beta. Okay, and cosine of alpha minus beta is cosine of alpha times cosine of beta plus sine of alpha times sine of beta. All right, so the next stage, what I'm going to do is I'm going to go ahead and substitute. So I'm going to take cosine of alpha. So now, right, my alpha is going to be pi over 4, so cosine of pi fourths, okay, minus beta, which is pi 6. So again, everywhere where it's alpha, okay, I'm going to put in pi fourths, so cosine of pi fourths times cosine of pi 6 plus sine of pi fourths times sine of pi 6, right? And there is my difference identity. Okay, well, now what I have to do is I'm just going to go ahead and I am going to substitute in these values. Okay, so cosine of pi fourths, this is going to be square root of 2 over 2. Cosine of pi 6 is going to be root 3 over 2, right? Plus, I have sine of pi over 4, okay, so that's root 2 over 2, and sine of pi 6, which is 1/2. Okay. Now we'll go ahead and simplify. So I have square root of 6 over 4 plus square root of 2 over 4, which gives us our answer, which is root 2 plus root 6 all over 4. And there's your answer. Okay, so that is cosine of pi twelfths, right? And maybe you want to include that over here. So this is equal to cosine of pi twelfths. All right, here is a practice problem. Please go ahead and solve this one. Okay, hopefully you paused it. Here is the solution. So you have pi 12ths is equal to 3 pi over 12 minus 2 pi over 12. You could also, again, use 4 pi over 12 minus 3 pi over 12, which would be pi thirds minus pi fourths. You could do that as well. But you should get the same answer. So root 6 minus root 2 over 4. All right. Okay. Now let's go ahead and look at a different angle. So here we have 17 pi over 12. Okay, and I want to come up with an angle that can make 17 pi over 12. So what I'm going to do is I'm going to use 15 pi over 12 and 2 pi over 12. Okay, so why did I use these? Well, these reduce to 5 pi fourths. Okay, and if here I reduce by 2, I get pi 6. Okay. Now you could use, again, anything that would add up to 17, okay, but they need to be unit circle angles. And again, right, this is a multiple of pi fourths, right, and a multiple of pi 6 over here, right? So I could go ahead and multiply these and get these angles. So those are my two angles, okay? So that's step 1. Step 2. I'm going to go ahead and identify, okay, what sum and difference identity am I going to use? So I have sine, so I'm going to go ahead and use sine. And then notice my identities here. My first angle is going to be alpha, second angle is going to be beta, and I'm adding them. So I'm going to use sine of alpha plus beta. I'm going to use the sum identity, all right, which says that sine of alpha times cosine of beta plus cosine of alpha times sine of beta. All right, and I want to go ahead now and substitute. So I'm going to substitute in, right, alpha, so sine of 5 pi over 4, okay, plus pi 6 is equal to sine of 5 pi over 4 times cosine of pi 6 plus cosine of 5 pi over 4 times sine of pi over 6. Okay? So I've just substituted in, again, my angles into the identity that I am using. So next, I'm going to go ahead and substitute in the values. Okay, sine of 5 pi over 4. Well, that is negative root 2 over 2 times cosine of pi over 6. Well, that is root 3 over 2 plus cosine of 5 pi over 4. Again, that's negative root 2 over 2 times sine of pi 6, which is 1/2. Okay. So this gives us negative root 6 over 4 minus root 2 over 4. Okay, and that would mean that, not cosine, sine of 17 pi over 12 is equal to, after I simplify, so we get negative root 2 minus root 6 all over 4. And there's our answer. Okay. All right. So here is a practice problem. Please go ahead and, oh, sorry, this one's not a practice problem. This is another example. We want to find sine of 5 pi over 12. Okay. So we have 5 pi over 12. And I have a feeling I can make this up with 3 pi over 12 plus 2 pi over 12. And after a while, you'll kind of start to get the hang of, like, okay, what fractions, right, can make up this angle. So 3 plus 2, right, makes 5. And I can go ahead, just to know the unit circle angles, right, I can reduce. So 3 pi over 12, that would give me pi fourths plus pi 6. Okay, so what identity am I going to go ahead and use? Well, I want to find sine, so sine of, and I'm adding, so sine of alpha plus beta is going to be my identity. Okay, so sine of alpha times cosine beta plus cosine beta times sine alpha. Alrighty, now go ahead and substitute in the values, right? So this is going to be sine of pi fourths plus pi 6. Okay, so sine of pi fourths times cosine of pi 6 plus cosine of pi fourths times sine of pi over 6. All right, so we'll go ahead and simplify now. So square root of 2 over 2 plus root 3 over 2 plus root 2 over 2 times 1/2. Okay, and here we get root 6 over 4 plus root 2 over 4. So here is our answer. Okay, so keep wanting to write cosine, so I can do a cosine. This is a sine problem. So sine of 5 pi over 12 is equal to root 2 plus root 6 over 4. Okay, and there you have it. All right, here is a practice problem. Please go ahead and try this one. There is a pi missing here for some reason, so make sure you see that pi. Okay, all right. Hopefully you paused the video and tried it. Here is the answer solution. So you should get root 2 minus root 6 over 4. And then here's another example. Okay, so what is cosine of 5 pi over 12? Please pause the video, try this one. Okay, hopefully you paused it. Here is the answer. So it should be root 6 minus root 2 over 4. All right, that'll do it for this video. Catch you next time. Peace.